Okay guys, we are starting lesson 6.3. This is the last of our congruence theorems. So first, is there a side-side angle congruence theorem? So I think Mrs. Davis already mentioned this in class, but if you didn't hear, there is not. And let's look at why real quick. So here in this diagram, we have side AB is 6 centimeters, and we have an angle. It makes an angle of 30 degrees with the ground or side AC. And then we have a second side that is 4 centimeters. But look at how BC is dotted. This is because if we draw the arc here and we have it kind of continue up like that, you can see it's going to touch side AC in 2 places. That means that we have two possible triangles. So if you look, it's going to touch the triangle here and it's going to touch the triangle here. So we have the possibility of 2 triangles. So that line, that 4 centimeter line BC, it could either go from B to C where it is there, it's dotted, or it could go here. So our triangles, we could either have one where B is the big angle here and it's obtuse, or we could have it be the smaller angle where it's acute. And of course, where it lands will decide what angle at C is going to look like, whether it's acute or obtuse. So the side-side angle congruence theorem is not valid because there's a possibility of 2 triangles with those measurements. And so it's not enough to prove your triangle's congruent. Okay, let's look at the last congruence theorem. So we have the hypotenuse leg congruence theorem, and we have that in a right triangle we have special names for the sides of our triangle. When it's a right triangle, you have the little square in the corner showing that that's a 90-degree angle. The 2 sides that create that right angle are called legs. How weird. Okay, it's gonna be weird. Anyway, there are 2 sides that create the right angle are called legs, and the side that's opposite the right angle is called the hypotenuse. So we've already covered the angle, side, angle, the side, angle, side, the side, 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 and the angle, angle, side. So today, the last one is the hypotenuse leg triangle congruence theorem, and it's special because it only works in right triangles. Only in right triangles. So the hypotenuse leg triangle theorem, congruence theorem, states that if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. So we can prove this using the Pythagorean theorem. So here we have triangle ABC and triangle DEF that are right triangles, and angle C and angle F are the right angles. And we are told that AB is congruent to DE and BC is congruent to EF. So in the Pythagorean theorem, A squared plus B squared equals C squared. So then D squared is equal to E squared, or excuse me, D squared plus E squared equals F squared. And it's given that AB is congruent to DE, so AB is equal to DE, and that means C is equal to F. So then C squared plus F equals F squared, and A squared plus B squared equals D squared plus E squared. And then it's also given that BC is congruent to EF, so BC is equal to EF and A equals D. Now we can substitute A for D in the above equations and have A squared plus B squared equal to A squared plus E squared. And then subtracting the A squared from each side, we have B squared equal to E squared. And then taking the square root, B is equal to E. So now we can that shows that AC is congruent to DF, and the triangles are congruent by side, side, side congruence. All right, so here number 3. We want to determine whether there is enough information to prove that the triangles VWX are congruent to YXW. So if we look at our triangle, we have WYX, this big triangle congruent to the other big triangle. And look, VW is congruent to YX, and we have our right angles, so we have right triangles. So our reasoning here would be that we have right triangles and with VW congruent to YX, we can also state that WX is congruent to WX because that's our congruence theorem. That's our reflective property. Remember, reflexive property? So now that we have the hypotenuse and one of the legs congruent in a right triangle, we can say that they're congruent by the hypotenuse leg congruence theorem. All right, so next thing, we want to apply the theorem of the hypotenuse leg triangle congruence theorem in a proof. So here we're given that angle P and angle R are right angles. PS is congruent to RQ, so we want to prove the triangle is congruent. So in our proof, the statements are the first two statements are the given statements, and then we can also say that SQ is congruent to SQ by the reflexive property, and so then our triangles PQS and RSQ are congruent by the hypotenuse leg triangle congruence theorem. Example B. Angle J and angle L are right angles, and K is the midpoint of JL and MN. So in our proof, we could say that, let's do it this way. So J and L are right angles because they're given information. And we can say that JK is congruent to LK and MK is congruent to NK. This is the definition of midpoint. And then our triangles are congruent by the hypotenuse leg congruence. Okay. So those are the reasons in this proof. So now in number 5, we have these triangles here. How weird. We have angle CAB and DBA are right angles, and AD is congruent to BC. So we're looking at the big triangles. ABC congruent to BAD. Okay, so we can say that AD is congruent to AD. That's reflexive. My pen's not cooperating, so my writing is especially atrocious. I apologize for that. This is the reflexive property. And we can say, oh wait, we didn't want AD to AD. We wanted hold on, I picked the wrong side there. We want AB congruent to AB by reflexive, because that's the shared side of the two triangles. And then we can say that CAB, the two angles here are congruent because they're right angles, and AD is congruent to BC. That was given. And then we got AB congruent to AB from reflexive. So now we have right triangles with a hypotenuse and a leg congruent. So we have the HL congruence. Okay. So, and if you weren't quite sure following along there, we've got this one is the reflexive property, and we've got AD this side congruent to this side because it's given. Okay. All right, what else? So here we want to determine what additional information is needed to show that the triangles are congruent for the reason given. So here in number 11, we want to prove our triangles congruent by ASA. To do that, let's look at what we've got. We have the two angles here at T are congruent. We have UT congruent because it's reflexive. So angle, side, angle means we'd need another angle. So we'd need the angles at U to be congruent in order to prove by angle, side, angle. Angle, side, angle. Okay? So the angles at U, that would be DUT congruent. That's an angle. I don't know why I did that. That's weird. Congruent to angle SUT. In number 12, side, angle, side, we have the reflexive side and we have our right angle. And they want us to use side, angle, side, so we're not using the hypotenuse leg here. But we could because they're right triangles. But side, angle, we would need this side to be congruent to this side. So that would be KX. Oh my gosh, this pen. So we would need KX congruent to WB. Alright, side angle side, again, here we would need, we have this angle and this side, so to side angle side means our angle needs to be between the two sides, so we would need CA to be congruent to LJ. And number 11, the hypotenuse leg, we would need, actually there's two possibilities here. We have the hypotenuse given to us, so we would either need this side congruent to this side, DE to VW, or we would need to know DF to VX. So either of those pairs would be appropriate here because they're both of those sides. Both of those pairs are a leg pair, so that would fulfill our requirements here. Number 14, angle side angle again. So we need a side between the two angles. So we would need DE to be congruent to JK. And let's see, move it up here so we can see it since that little watermark is in the way. We would need, for hypotenuse leg, we would need the hypotenuse says to be congruent for this to work. We've already got a leg CD to IH here, so we would need DE to be congruent to JI. Alright, and that would allow us to use the hypotenuse leg congruence there. Alright, now determine whether enough information is given to prove that the triangles are congruent. So the triangles A, B, C to D, C, B, and they are congruent, yes, by hypotenuse leg, because AC to DB are hypotenuses, and we can get CB as a reflexive leg pair, so this one would be congruent. PQR and STU. This one doesn't have enough information. What the heck is that? So we have one of the legs, we have a pair of legs congruent, and we know that's right triangle, but we would need the PR to be congruent to SU in order to prove this one. And so we don't have enough information. Number 4, GKJ to JHG. And we have these two sides, these four sides are all congruent to each other, and we can get GJ by the reflexive property. So this is side, side, side congruence. Alright. And EFG to SQR. So this one's tricky. You might look at this and go, we have a right angle and we don't have the hypotenuse, so we don't have enough information. And we actually do have enough information because we don't always have to use the hypotenuse leg congruence. The other congruences work in right triangles as well. So here we have side, angle, side, side, angle, side. So this one is congruent by side, angle, side. Okay. All right, proofs. Proofs. Let's look at our proofs. We are given that angle A and D are right angles and AB is congruent to DC. So we want to prove triangle ABC the big triangle, congruent to DCB, the other big triangle. So we have AB congruent to DC. We could say that BC is congruent to BC because that is the hypotenuse. That's the reflective property. Now we have the hypotenuse and the leg in a right triangle. So our triangles are congruent by the hypotenuse leg congruence. Next proof. Given angle FGH and JHK are both right angles, and H is the midpoint of GK, and FH is congruent to JK. This is all given information. We want to prove FGH congruent to JHK, the triangles. Okay, well, FH and JK are congruent. That's the hypotenuse. So we need to get one of the pairs of legs, or we need to get two pairs of legs, or another angle. So what can we get? Well, H is the midpoint of GK. That means GH is congruent to HK because that is the definition of midpoint. So now we have the hypotenuse and a leg in a right triangle. So we can say our triangles are congruent at this point by the hypotenuse leg congruence. Alright, number 8. Given MP is perpendicular to QR and N is the midpoint of MP and QP is congruent to RM, we can say MP is congruent. Let's see, what have we got? N is the midpoint of MP. So we could say MN is congruent to PN. This is the definition of midpoint. Oh, looks like I forgot one of my little things, so this is given. Forgot one of my reasons. Alright, so we have this hypotenuse and this leg, and we know they're right angles. Oh, we have to say that. It doesn't tell us they're right angles, it tells us that the line is perpendicular there, so we need to state that. MNQ, MNR, angle MNR are congruent because, oops, we're going to need another step. Okay, sorry about that. So we have the definition of midpoint. We can also state that MNR and PNQ are right angles because this is the definition of perpendicular. And so then we can say that the two angles are congruent because all right angles are congruent. Okay, and now we have our right angles, we have our hypotenuse and our leg. So now we can state that our triangles are congruent by the hypotenuse leg congruence. Number 9. So angles ADC and BDC are right angles, and AC is congruent to BC. That's given information. So then we can say that DC is congruent to DC by the reflexive property, and that gives us that we have right angles, so they're right triangles, we have the hypotenuse, and we have a leg. So now our triangles are congruent by the hypotenuse leg congruence. Okay, so here we have algebra again. So we want to solve for x to make our triangles congruent. That means that since they both look like they're the hypotenuse sides, we want to set them equal. 2x plus 12 equal to 5x minus 19. We want to subtract the 2x from both sides, and we want to add the 19 to the other side. So we have 21 equal to 3x, so x is equal to 7. Oops, it's an x. Okay, and number 11, we have x plus 8 equal to 3x minus 14. So plus 14 minus x to get the x on its by itself. So we have 22 equal to 2x, so x is equal to 11. And number 12. So we want them to be congruent, so we have 4x plus 2 equal to 6x minus 7. So plus 7 here and minus 4x here. So we have 9 equal to 2x. Is that right? Subtract the 4x and get 2x. Add the 7. Get 9. So x is equal to 9 halves equal to x. So plus 7 minus 4. Yep, I guess it's not going to work out perfectly there. Alright, and then in number 13, 7x minus 5 equal to 4x plus 25. So we want to subtract the 4x, plus the 5, And you can do them in separate steps if you need to see it, but I am just moving the whole numbers to one side and the x values, and then the x values to the other side, so that I have equations. So I end up with 3x equal to 20. And x equals 20 divided by 3. That just seemed really weird. Okay, this is wrong. This right here is y. So this was 4x plus 25. So when I add 5 to it, I get 3x equal to 30. So x is equal to 10. Okay? All right. So we are going to stop there.